In the last section, we expanded upon the API version and kind properties inside of both our config files. We're now going to start to talk about what a pod is, and then we'll very quickly talk about what a service is as well. Okay, so a pod. All right, quick diagram. Let's find it here. Here we go. All right, so just a moment ago when we went through that setup process to install Minikube and kubectl on your local machine, remember we installed Minikube and then we ran that command minikube start. When we ran that command, it created a new virtual machine on your computer. We refer to that virtual machine that is now running on your computer as a node. That node is going to be used by Kubernetes to run some number of different objects. Now, one of the most basic objects that you and I are going to create throughout this course is something that we refer to as a pod. And so when we start to load up this configuration file right here into kubectl, we're going to push into kubectl, and it's going to create a pod inside of that virtual machine that is running on your computer. And remember, we refer to that thing as a node. Now, the pod itself is essentially a grouping of containers with a very common purpose. Now, you might be wondering why we're making a pod that has a grouping of containers, when just a moment ago I had told you, oh yeah, we want to get something running as a container. Well, in the Kubernetes world, there is no such thing as just creating a container on a cluster. Back with Elastic Beanstalk, back with Docker Compose, we were creating containers willy-nilly all day, no issue whatsoever. But in the world of Kubernetes, we do not have the ability to just run one naked single container by itself with no associated overhead. The smallest thing that you and I can deploy is a pod. So we're always going to be deploying containers within a pod. That's the smallest thing that we can deploy to run a single container. Now you might be wondering, why is that? Why would we make a pod at all? Well, let's talk about why we would make a pod. So the requirement of a pod is that we must run one or more containers inside of it. Now, when I say one or more containers, you might very quickly think back to the multi-container application that we put together. Let's pull up a quick diagram of that thing. I've got one around here somewhere. Here we go. So back on the multi-container application we put together, we had our Elastic Beanstalk, and it was running multiple different containers all in this single little grouping. And so when I tell you that inside of a pod, we will run one or more containers, you might be thinking, oh, okay, that's it, like game over. We're gonna take our 4 containers or 4 images right here and create 4 of these containers inside of this one single pod. Well, that would definitely be an option, but it's not what a pod is meant to do. The purpose of a pod is the purpose of a pod is to allow the grouping of containers with a very similar purpose, or containers that absolutely positively must be deployed together and must be running together in order for our application to work correctly. Now, even when I say that, you might be thinking, well, Stephen, back here on this application, we had to have the Express server deployed with Nginx up here to serve the React application or respond to API calls. So you might be thinking, yeah, this thing had to have all these different containers put together to work correctly. Well, actually, that's not 100% accurate. You see, back on this application, if our worker container over here crashed for any reason, the rest of the application would still function a-okay. If the Nginx React server right here failed, well, everything would still pretty much work correctly. If the Express API closed down, well, everything else would at least kind of still function. In other words, if we take away the vast majority of these containers, the rest of the containers inside the group are still going to generally function the way we expect. It's definitely not ideal, but they would definitely continue to work. Now, in the world of a pod, when we start to group together containers, we are grouping together containers that have a very discrete, very tightly coupled relationship. In other words, these are containers that absolutely have a tight integration and must be executed with each other. So, as an example, let's imagine a pod that is running 3 containers that you see right here. This would be a good example of when we would use a pod with multiple containers. So in this example, I've got a Postgres container. So that's running the Postgres database. And then in addition to that, we've got 2 other containers. Now, these are imaginary images that I've listed here. So there is no image called logger that I know of. There probably is, but yeah, I'm just making this thing up. And I don't really know of any image called backup manager. So again, these are two imaginary containers that we're just kind of pretending exist. You could pretend that the logger container might need to connect over to Postgres and store some database logs. And maybe this backup manager needs to connect to the Postgres container and do a SQL dump or something like that and make a backup of all the data inside that database. And so again, this would be a very good example of why we would want to use a pod with multiple containers. A logger like this right here is 100% intended to connect to this Postgres container and pull some information out of it. If the Postgres container goes away, the logger 100% worthless. No two ways about it, the logger is completely useless at that point in time. And it's the same thing with the backup manager as well. The backup manager might need to reach into this Postgres container and pull out some information to make a database backup. And so the backup manager 100% has a very tight integration, very close relationship with the Postgres container. And again, if that container goes away, the backup manager, no two ways about it, 100% worthless. So again, in the world of Kubernetes, we make use of pods as the smallest thing that we can deploy. We cannot deploy individual containers by themselves as we could with Docker Compose or Elastic Beanstalk. Anytime we want to deploy a container in the world of Kubernetes, we have to make use of a pod. A pod can run one or more containers inside of it. Inside this course, you and I are only going to be running one container inside of any given pod. But reasons that you might want to add in more containers is if you have some other containers that have a very, very tight integration with other containers that exist inside the pod. So with all that in mind, if we flip back over to our client-pod.yaml file, again, we're specifying a object type of pod inside of here, and hopefully now some of the other configurations inside of here might make a little bit more sense. We are creating a pod that's going to run one container inside of it. We're going to give that container an arbitrary name of client. The name of client right here is, for our purposes, largely going to be related to logging and giving us the ability to reference this running container. But if we were running other containers inside of here as well, we could also use this name property to get some networking or connections between these different containers that are running inside the single pod. The image property, well, I bet you can guess what that is. That's the name of the image or the repository off on Docker Hub that this container is going to be made out of. And then finally, the ports entry on here is, it's kind of like that port mapping stuff that we were doing before. The ports of container port right here is essentially saying that on this container that we're going to create, we want to expose port 3000 to the outside world. Now you might be curious, why are we exposing port 3000 in particular to the outside world? Well, if you recall, back to our multi-client project, here's the source code for multi-client right here. There's the client directory. We had created a Nginx server that runs inside of that container, and it listens on port 3000. So we set up that container port 3000 right here because we're going to eventually want to expose port 3000 to the outside world. So this line, at least right here, is very similar to some of the stuff that we did back inside of our dockerrun.aws.json file with Elastic Beanstalk, and it's also similar to some of the stuff that we did inside of our Docker Compose file as well. This is setting up our port mapping. Now, one thing I want to be really, really clear about is that this is not the full story of port mapping inside the world of Kubernetes. This line of code right here alone is not going to give us access to port 3000 inside of our running container. In order to get that networking set up, that was the entire job of the second configuration file we put together. And so that's going to serve as a nice segue. Let's take a quick break right here. When we come back, we're going to start talking about the purpose of this service object that we put together inside the second file as well. So quick pause and I'll see you in just a minute.